Okay, evidently that was just six that happened. Okay, evidently I'm good now. Figure, right? Go figure. Hello, hi, hello, everybody. Hello. Get a chance. Let the notice go out there. Make sure we're all kind of getting in here. Good. Looks like I'm sound is good. Hello. Hey, Nathaniel. How you doing, man? How you doing? Let me get myself going here. Um, Hello, Katana. Hi. Let me put a little thing out to the thing. I'm just putting out a quick little thing to the Google chat there. 1 second, guys. 1 second. I'll be ready to go. I'll do that afterwards. Do that. Good. Let's go live. All rolling along here, right? There. Okay. Good. Okay. Yeehaw, right? Yeehaw. So let's tell a little story here in a second. What's up? What's up, Jeremiah? How you doing? So, tell a little story here in a second. Why am I on this? There we go. There we go. Got thrown off every time I was trying to go live with sixth grade. It would like give me a loop. It would give me a loop of sitting there saying, "Well, create a new stream," and it was just so ridiculous. Hey, Tristan, what's up? So, another quick story. The information that I was starting with yesterday, that I was starting to go over. During the video part, the little 40-second video, evidently the YouTube algorithms decided to to flag the 40-second waltz of whatever music they used. So there was like a copyright claim against that. So yeah, we're not gonna do that. So I apologize for wasting that time and that, but I'm not going to risk the channel getting something happening to it for some YouTube reason and whatnot. So what I'm going to be doing here, and if you astute people who look at Google Classroom, I went into Google Classroom and I took the packets here, the packets, and of course it's all three grades, but sixth, seventh, and eighth, and I took all three grades and I pinned that post to the top. I'm referencing these from now till when we're done here. So what's up, Nick? What's up? So I so when we so when dealing with this, I'm doing good, Nick. How you doing? So I'm going to be referencing obviously you guys the seventh grade packet. So if you have it up on your screen or if you had it printed out or whatever, I'm going to be referencing topic 8 for the 20-ish minutes that we have here. So let me get myself into that. But yeah, the moral of the story is don't mess with YouTube, evidently. So So if you guys were to get into this, you would be getting into topic 8 in this. So you'd be getting into topic 8. All right. So it's topic 8. So remember with these packets here, they're broken down into topics. So the curriculum that you guys we go through and everything is broken down into 8 different topics that you have. So in this one right here, it's dealing more with like a geometry part. Uh, I yeah, killer wasps. Yes, yeah, the killer or the murder hornets or something like that. Yeah, yeah. That evidently, the people are not as scared of the coronavirus, so now they let out the hornets. Uh, but, yeah, those things look those things look very very odd, very very odd. They're like something to where you would see in your nightmare when it comes to that there. Um, here, going here in just a second. All right, so topic 8, I'm going to try my best to get through as much as I can. But with that being said, let's get rolling here. Talk about geometry. Talk about all this good stuff. Let's just get right into the vocab of this. So we get right into the vocab of this. Um, Again, utilize crossing off things as you're getting them done, as you're going through these. So like in this instance, if I were to say, well, the distance around a circle is the blank. The distance around a circle, so if the distance, you remember me drawing this on the board, and I talk about the distance that goes from, that you measure around the circle, right here, around the circle would be the circumference. So that would be your circumference. Okay, circumference, as I can try my best to spell. Circumference would be the answer for your definition. Now the example is kind of like what I just drew right there. You're talking about measuring all the way around a circle. If you were to measure, around the bottom of this coffee, the bottom of this, coffee cup here, the distance around it, that's going to be a circumference on this. Okay, so again, I always stress, cross out your answer when you do it. You don't have to go back. You don't have to go back and do that. Am I frozen? Oh my God. Yeah, am I good here? 1 second, guys. I'm sorry. 1 second. 1 second. A very big wasp. Yes. You guys can hear me, right? Let's do this. Do that. There we go. Good stuff. There we go. There. That's much better. That's much better. Let me know if my stuff goes off here, but there we go. Okay. I had a little bit of an issue myself. Yeah, so one is circumference on this. So number 2, blank, 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 blank have a sum of 180 degrees. Have a sum of 180 degrees. Well, if you look at this and you say, well, look at your choices for the vocabulary. If you were to say, well, composite figure have a sum of 180 degrees, doesn't make sense. Vertical angles have a sum of 180 degrees. Maybe. Cross section makes no sense. Scale drawing makes no sense. Complementary angles could be. You either have your choice of complementary angles or supplementary angles. And if those of you remember going through this, complementary, think of complementary. Complementary is like, very, very, nice and concise, shorter, things of that nature. When you talk about supplementary angles have a sum of 180 degrees on that. Okay, so supplementary angles have a sum of 180 degrees. All right. Cross that out. Talk about supplementary, circumference. Number 3, a blank is the combination of 2 or more geometric shapes. 2 or more geometric shapes. If I drew a triangle and I drew a square underneath of that, that is what we call a composite figure. A composite figure. Comp figure. That is a composite figure. You're taking two figures and you're making them together. Houses, buildings, things of that nature are composite figures. They're not just generally one square house or anything of that sort. Number four, a blank is the two-dimensional shape that is exposed when a slice is made through a three-dimensional object. If I were to take a loaf of bread and I were to slice it, that slice that comes through is what we call a cross section. That is a cross section. Cross section. A cross section. Okay. We didn't get into too much of that yet, but that's what that is. Okay. Cross section. Let's roll down with this here. So we talk about with 8.1. 8.1, we talk about solving problems involving scale drawings. Scale drawings. If you remember scale drawings in this instance, they are ratios. It is actually one of the more easier ones to deal with. One of the more easier ones to deal with, just because it's just dealing with ratios. So in this instance, it says use a scale drawing to answer the questions. On this. So what is the actual area of the meeting room? In square yards. So if I have a meeting room, like you see right here, if I have a meeting room, and this meeting room is 1.5 inches by 4 inches in the scale drawing. Well, how do you find the area first? The area on this, obviously, the area on that rectangle, if you remember, obviously is length times width. So if I take 1.5 times 4, 1.5 times 4, if I take 1.5 times 4, it will give me 6. It'll give me 6 on this. So in our scale drawing, it is 6 inches. So if in the scale drawing, it's 6 inches. The proper way of then finding, well, how big is that in square yards? You find that your scale, let me change my color here. If you find my scale right here of 1 inch equaling 3 yards, I can set up a ratio. Obviously, you can do this in your head, but this is if the scale was something different, it'd be a lot more difficult to figure this out. But in this instance, 1 inch over 3 yards, and we know that in the figure is 6 inches over what we don't know, which is x yards. Okay. If you cross multiply, you know that you get 1x on one side. And on the other side, 6 times 3 is going to be 18. You'll find out that dealing with that, it is going to be 18. And that's not it. My God. There we go. Oh, and then times by 3. 24. 4 carry 2 would be 54. There we go, because it's the inch. There we go. Okay, there we go. Good stuff. Let's go through here. Let's go. Let's actually go down to everybody's favorite angle relationships right here. Everybody's favorite. So, when you talk about supplementary angles, complementary angles, vertical angles, all that stuff, when you guys had those nice, wonderful, large, big tests right there. So, in this instance, we want to use the figure from the example. So every answer will come from over here. Every answer is going to come right from over here. So name a pair of complementary angles. Know that the complementary angles are what ends up creating a 90-degree angle. So the two angles that create a 90-degree angle on that. So two of those right there nicely shows the label for a 90-degree angle here. So what two angles make up that 90 degrees? Well, you can look at this and you could say, well, angle Q. Why am I writing it right there? Angle Q Z X and angle X Z Y. Again, the two angles that are complementary. It's like you're taking this angle, and you're adding it to that angle. You add those two up, and it makes the 90 degrees. So those would be your two complementary angles. Okay. So the measure of angle XZY. So the measure of angle XZY is 55 degrees. Which other angle has a measure of 55 degrees? So if XZY is 55. What would be the other angle that has a 55 degree angle right there? Well, remember the term vertical angles. Vertical angles is what shares that common vertex here. It's what shares the common vertex. So it shares that common vertex. You know that angle SZR, so at angle SZR is going to be 55 because it is vertical to XZY. And vertical angles are always equal. So angle SZR, angle SZR. All right. And then the fun part, using the information from problem 2. So we found that angle SZR is 55 degrees. So if SZR is 55, we can then find the value of n. So if we want to find the value of n, all right, we can find the value of n. Well, let's see here. We know that this angle XZY is going to be 3n plus 5. So if I take 3n plus 5, I can set that equal to its vertical angle of 55 degrees. Because if this angle equals this angle, I can create this equation right here. I hope that makes sense. I know I'm going quick, but I hope that makes sense a little bit there, guys. So with that being said, so let's sit there and let's run through this. N plus 5 equals 55, right? So minus 5 minus 3n equals 50. Let's see, what am I doing? There we go. I'm going to have to come back to that one there, guys. That's not matching up with what I have. Those of you following along, if you see what I'm doing differently, please let me know. Just for time's sake, I'm going to keep going here. There, okay. Yeah, man. Okay. Let's look at this. Look at number 2. Let's look at number 2. Let's talk about a little bit about circumference. So if the circumference of a bicycle tire is 126.5 centimeters, what is the diameter of the tire? What is the diameter of the tire? If we remember, circumference equals pi times the diameter. So pi times the diameter. If the circumference is 126.5, and it says to use 3.14 for pi, you're filling this in. And when you divide both sides by 3.14, you divide both sides by 3.14, you're going to find that the answer gives you that nice long 40.2866 and all that kind of good stuff. When we round this to the nearest tenth, remember your nearest tenth is going to be the one that is directly to the right of the decimal. The one that is directly to the right of the decimal. You then look to the next number to the right, and in this instance, it's over 5, so we're going to raise that tenth. So 40.3 would be your circumference. 40.3 centimeters. 40.3 centimeters would be that diameter of the tire. Okay. Doing almost good here. What's up, Hope? How are you doing? How we doing? I appreciate you guys sticking with me on this. I know it's definitely a different, different animal with things here. So let's take a look here. Let's try to find a good one that I can kind of roll through kind of quick. So we say, well, what's the diameter of a circle with an area? So with an area of 113.04 square centimeters. Okay, we'll finish up there with number 2. We'll finish up with number 2 on the next one. What's the diameter of a circle with an area? So if I have area equals pi r squared, okay, the area of 113.04 equaling pi, which is 3.14. The radius squared you don't know yet. You can then divide both sides by 3.14 by 3.14. All right. And when you do that, it's going to give me 36 equaling our radius squared. Now, are we totally done with this? No, we're not done with this. If we have our radius squared, the inverse of squaring something is going to be taking the square root. So you take the square root of both sides. Our radius will equal the square root of 36. So what is the square root of 36? And that, my friends, is the number 6. So the question tells you is, well, what's the diameter? Well, the diameter, remember, the diameter goes, as you see right here, the whole way across. What you just found, though, what you had just found was only half. The radius is half, remember. Radius is half. The diameter is the whole way across. So in this instance, we take the 6 and we just multiply it by 2 to give us our diameter of 12. 12 centimeters will be our diameter. Okay, guys, I hope that helps a little bit right there. If you have any questions, please send me an email. Reach out to me over Google Classroom. I'll be more than happy to answer you through there. But yeah, I mean, it's just kind of going through a little bit of things there. I know it's not a ton that we've it's not trying to get through as much as possible with this, but just know that we're trying to get through as much as we can. This is a different animal. Hope you guys have a good week. If you have any questions, please send me an email, reach out, all that kind of good stuff. Hope you guys stay safe. Stay safe. Take care. Talk to you later, guys. Bye-bye.